Okay, today we're going to do creating Lewis structure for a covalently bonded molecule. Okay, covalently bonded molecule means that we are showing the bonds in the Lewis structure by using electrons, or electron pairs is probably a better way to say it. So let's go on, and I'm going to give you a little time to copy this down. And those of you watching at home, just copy this down. You're not going to really understand it, but you will be able to use it when we get into the next part of what we do. But for right now, total valence electrons must add up. Each atom must have 8 electrons, and there's 3 exceptions. And that's hydrogen, beryllium, and boron, and their numbers are 2, 4, and 6. And that's the number that's required. Not more, not less. That exact number. So that will keep you in good shape when you finally understand what that means. And then knowing the 5 shapes. Okay, be sure to get those 5 shapes down. If you want a little help on that for how to draw them, it's available for you on page 260. So would you all turn there right now? Page 260 in your textbook. And you'll see those shapes. Okay, and it's the top 5 shapes on that page. And the last thing here, if you run out of electrons, do more sharing. And that doesn't mean much to you right now either. So just take it down, and what will happen is as we go through the next few screens and actually work things out, you're going to remember back to this page and the next, and it will make a whole lot more sense to you then. Okay, so let's go ahead and get over to the next page. This is available for you online in 2 forms. You can either pick it up in the video, or you can pick it up by simply going to the whiteboard file like you always do to pick anything up. Yes? No. So, no harm asking. Now, this line means 2 electrons. For those of you here in the class, it would be a good idea for you to get out your phones and take pictures, because I'm going to move a little too fast for you to take good notes. Okay, so in this screen, I'm just showing you one part of it at a time. So the lines here mean 2 electrons, and those are always bonding electrons. When you see dots like this, the dots are equal to 1 electron only, and they are never shared electrons the way we do it. There are some books and some teachers that use dots for all electrons, whether they're bonding or not, and I just like to have the bonding pairs very clearly different from the unshared pairs. And the last thing you're going to need to know about is electronegativity, because the central atom, notice, central atom, has the lowest electronegativity. And we'll see that in practice in just a second. Okay, if you're not done, take a picture, and we got to move on. Now we got to get into actually doing it. And this is where it's all going to start making sense. You do not need to take notes on this part, so I'm just going to read it to you. We want to count total electrons. We have to do that. We're going to place the atoms where they belong in relationship to each other. And each to the central atom, each electron sticks, each of the sticks going between atoms is going to bring us 2 electrons. And the 2 atoms will share those 2 electrons. And so we count those electrons for both atoms when we're counting how many each atom has. And then we pass out the remaining electrons so that everyone gets 8. So let's make this make sense now. We have water here, H2O. Most of you have seen this before. Okay, so that's not a strange formula. However, now we have to decide who is going to be the central atom. So who do you think that should be?
Oxygen.
Oxygen. Why should it be oxygen? Go ahead.
Because oxygen should be surrounded by...
Why?
Because it's one. It's a one.
No. Absolutely wrong. It's okay to be absolutely wrong right now. Don't be at all worried about that. But that's what most people will guess. And by the way, most of the time that would get you the right answer. But it's important to know why. So what did I just say in the last screen?
Lowest electronegativity.
Lowest electronegativity. Okay, so who would have the lowest electronegativity between hydrogen and oxygen? Mm-hmm. So you would think oxygen should be in the middle, and it is. Okay. Now I want to show you, don't copy this down, but I want to show you what happens if you decided to make it hydrogen instead. I'm going to bond our atoms together because we've just come to the conclusion that we think hydrogen should be the central atom. Okay, now how many electrons can hydrogen handle when it's bonded? Go ahead. No, that's how many he has to give. That's how many bonding that's how many valence electrons he has. Okay? 2. Yeah. Look at your notes. Here, go back. Okay, remember he's one of the exceptions. So as you go to the periodic table, unfortunately on the recording you're not going to be able to see me do this, but I'm pointing in the periodic table to hydrogen, and then I go down and to the right one box, and that gets me beryllium, and then I go across the valley where we have the transition elements over to boron. And as I go from hydrogen to beryllium to boron, the number of electrons increases by 2 each time. So we have 2, 4. I'm pointing to hydrogen as 2, beryllium is 4, and boron is 6. So that's really nice to help you remember what those numbers are. And now we're going to go here and we're going to say, all right, how many does this hydrogen have? I should be doing the pointing so that everybody can see on the video. Okay, so how many does, whoops, yeah, how many, come on, oh, it's not working like it used to. Okay, at any rate, here's the hydrogen, and I'm looking at that hydrogen. He has 1 stick next to him. That means he has 2 electrons. So this hydrogen has 1 stick over here, which has how many electrons? 2. How many on the other side? So how many does hydrogen have if we place him this way? 4. No good, right? Can't do it. Hydrogen can never be a central atom. Okay? So that's the lesson to be learned from this particular screen about hydrogen. Okay? So that's why we're putting the hydrogen over here on the right side. Now we're going to go over here. I put the word atoms and valence electrons to let you know what I'm putting up there. So let's look at oxygen. How many atoms do we have in the molecule? 1, yeah. And how many valence electrons does oxygen have? 6, correct. Okay, he's atomic element number 8. But atomic element number 8 is in column 6. Okay, so he has 6 valence electrons. And when we multiply that out, we get 6. And now we have hydrogen, how many? 2. And how many valence for each hydrogen? 1. So that gives us 2 more valence for a total of 8. And the total is what I was talking about in that first page of notes that we did. So our total's 8. Now, how many have we already put into the Lewis structure? Yeah, we got 2, 2, 4. 2 here and 2 here. So we're going to subtract those. That means we have 4 electrons left to pass out. Can I give electrons to either of the hydrogens? Why? They already have 2, and that's all they can have. Okay, so I'm going to put my 4 electrons on the oxygen because he wants 8. And now I should have a good Lewis structure, but I'm going to double check. So in my double checking, what I want to do is start at any place, it doesn't matter. I'm going to start here, and I'm going to count 2, 4, 6, 8. That's the correct total. Okay, now I have hydrogen. That hydrogen has 2. Notice I'm counting those electron pairs twice. Okay, I counted that for the oxygen. I'll also count it for the hydrogen because they're sharing. And each of them gets a noble gas configuration. So hydrogen's noble gas is what? Element number 2 is helium, yeah. And oxygen, who's his noble? Look at the end of his row. Right, this is noble gas configuration for neon. So we're good to go. We've got 8 for oxygen, 2 for each hydrogen, and our total electrons is 8. And now we can go on. Let's go to carbon dioxide. Here we go. Who's in the middle? Carbon, good. Okay. We'll put oxygen on either side, and then we're going to go ahead and say, how many atoms? Carbon do we have? 1. Times how many valence? Carbon. Carbon's in column 4, so we get a total of 4. And oxygen, how many? 2. And the valence? 6. Gets you 12. You cannot get credit for the homework unless you do these numbers. Because if you don't do these numbers, you are just totally guessing on what the Lewis structure should be. And you might guess some of them right, but I want you to learn how to do it and make it right so you get your answers to everything correct. So we've got 16 here. So how many in the Lewis structure so far? 4. Good. So we're going to subtract that 4 from the 16 to get 12. And now we have 12 to give out. Now you can put them anywhere you want, but I recommend you do it my way because it's faster. Okay? And we all want to get our homework done faster, right? Faster than slower. Okay, so 12. Here we go. So 2, 4, 6, 8, 10, 12. Oh, darn! I ran out of electrons. What do I do? More sharing, Ellen. Excellent. Okay, more sharing. Now, who could share with this guy? Oh, the other oxygen could share. Yeah, so let's go ahead and take those 2 electrons and put them over here. That gives us a good start. Now, could carbon share with oxygen and still have 8? Share, not give. Share. Yeah, you could share. Sure. So what we're going to do is zip out those 2 electrons and move them into bonding position, which means that now they will be a stick. Now, how many electrons does the left-hand oxygen have? 2, 4, 6, 8. Hey, good deal. All right. And how many electrons does carbon have? 2, 4, 6, 8. Hey, we're doing pretty good. How about this oxygen? 6. Who could share with that oxygen so that you'd have 8? Carbon again. Carbon's got to be the big, magnanimous giver of electrons. And there he goes. Okay? Now, let's check it out. Make sure we didn't miss anything. Sometimes when you... By the way, did you realize you'd need to do this with pencil? Yes. Okay. So, especially as you're just getting started, because you're just kind of trying to get the hang of it. So let's go ahead and check out our total. Make sure that our total is correct. So I'm going to count them with the pointer. And so here we got 2, 4, 6 for the top line and 8 for the bottom line. Gives us 8 electrons for this guy. 2, 4, 6, 8 for carbon. And 2, 4, 6, 8 for oxygen. Everybody has 8. And we have 16. Let's check it out. 2, 4, 6, 8, 10, 12, 14, 16. Bingo, we got us a good Lewis structure. Now that we have a good Lewis structure, we need to find out if we can name this guy. Okay, what are our two choices for this? What two could it possibly be? No, the shape. It is carbon dioxide. But the shape could be linear. Yeah. Okay. What is required for linear? Can we have unshared pairs on the central atom? Let me show you what unshared pairs does. This is the same situation. I have a water molecule, and above the oxygen in the water molecule, we have 2 unshared pairs above it. And for that reason, this guy is bent. Okay? He is bent. So, to be able to make him go straight, we can't have unshared pairs on the central atom. So, for this reason, no unshared pairs on the central atom. Because of that, we can call this guy linear. Now that's a linear molecule. Okay? We're good. Let's go on. SO2. Let's get this guy. Who's in the middle? What? Sulfur. Okay, where is sulfur in relation to oxygen? It's below it, right? So the trend is that in a column, the electronegativity goes up as we're moving up the column. That makes sulfur in the middle, and let's go for it. And we're going to look at sulfur and our sulfur dioxide, and our last little dude that we did is carbon dioxide, and this is going to be sulfur dioxide. We're going to see a difference. So how many sulfurs do I have? 1. Okay, sulfur 1, what's the valence? 6, so we got 6 electrons. Oxygen, how many? 2 times valence of 6 is equal to 12. Oh, that's a terrible 2. Okay. Anyway, 12. So this guy's 18. And now, that's our total. Remember, we got to get the totals right. So we got a total of 18 electrons. How many are in there already? 4. Good. And now we got 20. Whoops. Oh, I'm doing terrible here. 22. Oh, wow. I'm adding this. Yeah, okay. So I'm subtracting that out, so we got 14. Yes, thank you. Now we're going to pass these guys out. Here we go. So we got 6, 8, 10, 12, 14. Ran out again. Whatever can we do? More sharing. Who's going to share? Why would you take away from oxygen? If you take away from oxygen, you leave him with only 6. Who could share? Sulfur should share. Okay, so sulfur, we're going to take his 2 electrons and let's put them in right here. And now we have, let's count them up, 2, 4, 6, 8 electrons for the left-hand oxygen, 2, 4, 6, 8 electrons for sulfur, and 2, 4, 6, 8 electrons for the oxygen. So everybody has 8. Do we have 18 total? 2, 4, 6, 8, 10, 12, 14, 16, 18. We have a good Lewis structure. Now, and only now, can we say, what is it going to be? Is it going to be bent? Does it have unshared pairs on the central atom? It does. It doesn't have to be 2 like you see in the model that I'm holding up. But this guy doesn't have any, and that made him linear. Okay, so let's go ahead and type in here unshared pairs are on the central atom. And that means that we have a what? What's the shape? Bent. Yep. And so, because it's bent, we know that those unshared pairs, this guy up here is shoving against this. He's also shoving against this. And that gives us a bent shape for the molecule. And so now we're going to go over here, and let's do boron trifluoride. Wow, that's a mouthful, isn't it? Who's in the middle? Boron is the dude. Okay. And how many fluorines do we have around him? 3. Okay, let's just tie them in with the sticks. Yeah, that's sticks. And we got fluorine, fluorine, and fluorine. And now, how many atoms? Atoms. Let's start with fluorine. How many? 3. Okay, that's, this thing is a little out of alignment. There we go. So fluorine, we have 3 times, what's the valence? 7. And that gives us 21. And then we have boron for how many? 1 boron, and how many valence? 3. 3 and 21, you get 24 as your total. And now, how many are in that Lewis structure already? 6, good. So we're going to subtract that out, we get 18. And then we go back to the Lewis structure, and we got to pass out 18, right? 2, 4, 6, 8, 10, 12, 14, 16, 18. Wow! Everybody got enough. Or did they? How many does boron have? 6. Is that good? 2, 4, 6. We look back, and we see that that is indeed good, because boron is one of our exceptions. And so we go back here, we know that our boron is good. And here's the way I like to count things when you have similar things. You see the fluorine, each fluorine has 8 around it. So in my mind, what I'm doing is I'm taking the 8 and I'm going to multiply by 3. How many electrons does that give me? 8 times 3 is? 24. Not 18. 18 is what we had left after we took out the sticks. Okay? So, we're good. We have a good Lewis structure. Now, is this going to be trigonal planar or trigonal pyramidal? How do we know the difference? Unshared pairs on the central atom. Okay, trigonal plane, trigonal pyramid. Wow, it's a plane, isn't it? Because there's no unshared on the central atom. And so this is going, because the reason there's no unshared pairs on central atom, that makes it a trigonal plane. Trigonal planar. P-L-A-N-A-R. Well, that's not written very well. The screen's out of sync with the computer. Anyway, let's move on. One more here. I think that's it. No, two more. So I'm going to go real fast on these guys. Ammonia. We've got nitrogen in the middle because we know it can't be hydrogen. And we got hydrogens on the outside. I think you're probably beginning to get the idea by now of how this works. We got one nitrogen. His valence is? Valence is? 5. What column is he in? He's in 5. Yeah. So he has 5 valence electrons. It's equal to 5. And we have hydrogens, 3 of them, times 1. That gives us 3. Total is 8. And that's what we have to have in our Lewis structure. How many do we have in the Lewis structure right now? 6. Yeah, I forgot to put that in like earlier. So we take that out and we get 2 left. Oh my goodness, where in the world will we put that last 2 electrons? Nitrogen, of course, because hydrogen can only take 2. Now do we have a total of 8? Let's check. 2, 4, 6, 8. Good. Nitrogen has 2, 4, 6, 8. I should be doing that over here. That's 2, 4, 6, 8. Now you people at home can see what I was pointing at. And then this hydrogen has 2, this hydrogen has 2, and this hydrogen has 2. So everybody has the right numbers. And what is my shape going to be now? There's unshared pairs on the central atom, so what does that mean? Yeah, unshared pairs on central atom. So because that, we've got to have a trigonal pyramid. Trigonal pyramid. Now let's look back. Let's compare a couple of things. I think I'm going to be able to get that to work. Yes. See the difference between the trigonal plane and the trigonal pyramid? See on the right hand side where we have the ammonia, we've got unshared pairs. So that became a pyramid, and this boron trifluoride is a trigonal planar. And I think we had the same kind of thing here with these two guys. See? This one was linear, the carbon dioxide. This one was bent because of this 2 pair of electrons right here that forced this pair of electrons and these 2 pairs to move away by repulsion. So we're good. Let's go back now and get this last guy, and we're going to be done. So we got carbon in the middle, hydrogen, 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 1, 2, 3, 4, and carbon. How many atoms? 1. Valence is carbon? 4. So we got a total of 4. Hydrogens, we have 4. What's the valence? Valence is 1. Yeah, don't confuse the valence and how many he has to have at the end. How many he has to have at the end are part of the bonding. But when we do what we're doing right now, this is counting what's going in. Okay, they're all going into a common pot. And so we have to have 8 electrons total. Oh, wow. 8 valence electrons total. So let's count. 2, 4, 6, 8. Yeah. Everything's there. So what are we going to call this guy? Tetrahedron, yeah. Okay. So this is tetrahedral. That's 4 atoms on central atom. And the last screen is the reasons that I was using. Okay? And it tells you to which kind of shape each of those reasons applies. Thank you for watching. It's a long video. I hope you find it very helpful.